Hi everyone, we're gonna be starting soon, so get tuned and yeah, we'll get started briefly. Well, hello everyone, it's Nono here. We are gonna get started a bit earlier than it was scheduled. I'd like to say hello, it's Nono Martinez Alonso for those of you who are connected or are connecting for the first time. Today we're going to change a bit topics. We're going to leave aside the ML detector work that we were doing last week, and we're going to focus on StyleGAN. We have been seeing StyleGAN throughout different streams, and we haven't really done a full-on workshop or hands-on tutorial on the live stream yet, where you can see how to get your own images and get a Google Colab notebook and train your own model. I have recorded tutorials on how to start using Runway ML and also how to train StyleGAN with Runway ML, but I haven't yet shared those on YouTube, but hopefully we'll see them in the next week. So let me go here and introduce a bit what we're gonna see today. So here I have 3 topics. So we have training, StyleGAN, the sketch detector and auto cropping. Honestly, I don't think we're gonna have time for sketch detector and auto cropping today, and we're just gonna stay on training StyleGAN. But I like to put a few more topics just in case we have time. Hello, Suje. Nice to see familiar faces around. And sorry for those of you who might see the stream later or are connecting late, because the stream was scheduled for 1 hour, almost 1 hour after it actually started. This is just, I've had a bit of problems scheduling today. So yeah, we're going to get started a bit earlier. And hopefully for those of you who don't get to see it live, you can skip to the guts of it, and we're going to see a bit of a recap. All right, so let's see if I can use this clicker. I would let you know that you can like the video to support the channel and support the work that I'm doing here with the live streams and with the tutorials. It really helps. And subscribe if you're new and you want to get notified when I go live next or when I upload new videos. I would also take this opportunity to ask you, for the guys that are online, to let me know if you can see me okay and if you can hear me okay. That way I know that I'm not, I'm not muted or that the audio is low or something like that. All right, the Discord community. If you go to www.nono.ma/discord or just go to that QR code up there, you're gonna get an invite for you to join the Discord server. This is the chat that we're using to talk about live stream, about machine learning, about the podcast, the Getting Simple podcast, about sketching, writing, and many, many things. So go ahead. If you want to join us, you can chat with us there and you can reach us out. Last week, we saw, as I mentioned before, the ML detector. We went through data labeling, dataset preparation, GLB5 training. We also covered RoboFlow, something I hadn't thought of covering during that live stream. And we also saw how to train GLB5, but we didn't really get to great results, right? We didn't achieve, there was something weird because the classifier, so the object detector wasn't returning anything. It wasn't returning any results. So that, that's not great. Thanks to Jeff for letting me know. Okay, and yeah, one of the main things that you can learn from the past 2 live streams is how to run a local copy of CVAT. This is an open source labeler that you can run on your machine or in remote servers. And we see in previous videos how to do that in depth, how to run it in Docker on your machine or in a DigitalOcean droplet that's on a remote machine. And, we see what it is, what you can use it for, and we use it for an example. This week, I published a short story called White Nights Watercolors. This is one of the post series that I'm doing to share the tools that I use for my sketches. And let's discuss what we're going to do today. So we are going to do live stream 23 today, and that's going to be, 23 weeks already. And I hopefully can continue scheduling these Thursday live streams as the weeks go. Even, I don't know, maybe even when I'm on vacation. The first thing, let's see StyleGAN. So I'm going to give you a quick overview of that. There is a detailed live stream where I show the experiments that I did to hallucinate sketches and portraits with StyleGAN. That's live stream 18. So you can go back there and see a lot of more details of what I'm going to pass through quickly today. This is an experiment I did where, these are my real sketches, and these are sketches that are generated by StyleGAN. From afar, they look similar, but they're really not. They look more like this. This is what's called a latent space walk. It's an interpolation from different points to different points of the trained model. And, I selected the ones that looked like buildings and made an interpolation only between those. And I also selected the ones that look like bags or something brown, and also made an interpolation just with those. So this is StyleGAN2. It's a model developed by NVIDIA, and it requires a special CUDA drivers or plugins to run. So these are custom operations that can only run on specific NVIDIA GPUs. So you won't be able to run it on your machine on CPU even if it's slow. Like it won't run. So you need to have access to a machine that has those drivers. An example is Google Colab, is what we're going to use today. And here we have more sketches, a selection of them. And then this one that is with the portraits dataset, this is interesting to me because I trained this model, or I achieved this result by just training with 8 images and then augmenting the dataset. And you can see that on Livestream 18 as well, I think. All right, so let's get to code. I think, yeah, those are the slides that I had for today. And, you know, let me quickly go and look for something else. Switch off 1 second, just gotta browse through some of the previous presentations that I've prepared. Let me just take a look at this here. Okay, so I have Dropbox deactivated, so I cannot access some of the presentations. And you know, on this kind of interlude, while we wait for some other people to connect as well, I would ask you if you have any specific questions, any particular questions that you want to ask for what we're going to see today or about past live streams. Okay. All right. Yeah, it seems I have the presentations here. Okay. Yeah, so what I'm going to show now, so let me see if this is the right presentation. Yeah, so we have a set of recorded videos, right? You should see that right now. Okay, we have a set of recorded videos that are still to edit and be uploaded, but they go through this tutorial, which is how to do what we're gonna do today with Colab, but do it with Runway ML, right? We go first throughout the process of dataset creation. So we see, you know, what it means to train, which in some ways going from those phases to whatever dataset you have. There's like a dark area there from the original dataset we're training from till the one that actually looks like your images. And long story short, ideally you have 5,000 images that sort of look alike or have the same style. You have images that are 1024 by 1024. This is the highest resolution at which we can train. And you have, or at least in Runway, you train for 3,000 steps. I think that costs $15 in Runway, and it can cost up to 25, or, you know, you can go even higher if you train for more steps. And you can save checkpoints at different steps of the process. And then the second part of those tutorials, this is kind of a promise that I'm making because those are still not edited and they need to be uploaded, but they are recorded already, is on how to train. So this, I do an experiment with almost 5,000 images, size that is landscape, not portrait or square, and then 3,000 steps. And then instead of using these images, we convert them to square, and then we train with square. Because if you add padding, black padding to the top at the bottom, you're actually losing information. And you can train with square images, and if you want to have the real resolution, you can squeeze them after the output is generated. And, you know, after some hours, you get that the experiment has trained on Runway, and you can download these sort of latent-based video walks. These are auto-generated. The ones I showed before, I generated with the Google Colab notebook. And then this is another interpolation, and these are other tests with the different training sets. All right, so that was Runway, and you know, you would go and click on train here. You would see the different processes on the training process, then while you're training, you would see that you can actually move through the different parts. And then there's this FID score, that the lower the FID score, the more your fake or like synthetic images resemble the originals. And then you have the steps. So in this case, there's 2000 steps have gone through. And then the estimated time, like it tells you that 1 more hour needs to happen or pass. And then there's the C vector, which is the actual input to StyleGAN, which is 512 float numbers. I think they go from -1 to 1, and varying those ones as an input provides a different output in the model. And this is just like using the colorization algorithms there. All right, so that is a quick overview of the slides that we'll upload the tutorials for. So we don't have those edited yet, but we will. So we will upload them. And now, so let's get started. So we've gone through a bit now, and we can now get started. So the first thing I'll do is let's close Keynote for a second, and we'll open a Google Colab notebook that I have. Let me see. And this Google Colab notebook, well, this is just a folder to which we're gonna save our files. So I have a Google Drive account. I imagine that if you have Google Colab, you will have it as well. And note that when you go to Colab, if we were to open a notebook, so in this case, I'm going to open one that I created today, a copy of the StyleGAN notebook that I have. I'm going to open that one, and you're going to see that right now my Colab account is not Pro anymore. I haven't renewed my subscription, and I'm going to do that right now. And you would see that here. You would see here the Colab Pro. So this is just an example. So maybe let's record quickly a video. So let's record a quick video on how to do that. Let me go to the right and right. Well, hi everyone, it's Nono here, and we're gonna see how to create a Google Colab notebook and how to upgrade our account to Google Colab Pro and get access to better GPUs and higher RAM times. So we first go to colab.research.google.com. So that's just entering the URL, and we'll get access to this panel. So let me actually do that again. So we go to the main page, and then here we can either close this menu and just see the Welcome to Laboratory notebook, or you can create a new notebook by pressing this button. So we press that button, and now we're going to create a new empty notebook. We get a unique URL for that notebook that we can see up here. And that unique URL you could share with anyone, but if you share it directly, that notebook belongs to you, to your Google account, and you're gonna have to sign in. But if we want to share with friends, so let's say we say like public notebook, and this is from live stream number 23. So we can do share. So let me just go back there. So we can go here to this button, share, and this is something we're gonna do today. We see that this is a restricted notebook. So and only people added to it can access with this link, right? So I could add here somebody by email, and what we want to do now is that we're going to change to anyone with the link. So we would now be able to copy this link, and in an incognito window we could access the notebook, right? Anyone can access this notebook now. I'm gonna put a link to this notebook on the live stream. So let me just put here links. links for live 23. All right, and I'll put that. All right, so that link now, if you open it, you're going to be able to access it. I'm not sure about editing. I don't know if you're going to be able to edit. Shared links will not contain your edits or outputs. To include your edits, blah, blah, blah. All right, so we can go there, and now that's public. You can access it, and I could do something like this, and then just bring the TensorFlow version. So once you do that, right? So if I click here on connect, or I simply try to execute one of the cells, then we see that the notebook is connecting to our runtime. And you know, if you hover this, it will tell you some information about the machine that we have connected to Python 3, Google Compute Engine backend, and the RAM and all that stuff. We have TensorFlow 2.4.1. If we go to runtime, change runtime, we see that we're not using any GPU. So we could use GPU or TPU for free, but we will get better GPUs if we update to Google Colab Pro and some options here for high RAM machines. So we click save, and let me just see here. So if we run this snippet of code, we see that we have access to, you know, the Python 3.7, TensorFlow 2.4, and we have access to a GPU, right? We have some information here. Let me now upgrade my account again to Google Colab Pro, and I'll continue. We'll see the higher runtimes. All right, and I'm gonna go here for a second. Okay, and I see as well that Mamadou Kali, so Kali is connected. Hello, want to say hello to, I see familiar faces. Thanks for joining us. And I guess now I'm going to go to my account. So let me share once more here. So here I will go to Colab Pro and then learn more. So here we just have like a message to upgrade now, and you just have to put your information there. You can see that what kinds of GPU are available. With Colab Pro, you get priority access to our fastest GPUs. For example, you may get access to T4 or P100 GPUs at times, when non-subscribers get K80s. You also get priority access to TPUs. There are still usage limits in Google Colab Pro, though, and the types of GPUs and TPUs available in Colab Pro may vary over time. In the free version, there is limited access to faster GPUs. Usage limits are much lower than they're in Colab Pro. How long can it run? Colab Pro, your notebooks can stay connected for up to 24 hours, and idle timeouts are relatively lenient. Durations are not guaranteed though, and idle timeouts may sometimes vary. Free Colab has 12 hours. How much memory? Well, you get high memory virtual machines. Why aren't resources granted? In order to offer faster GPUs, longer runtimes, Colab needs to maintain flexibilities. How can I get the most? Our priorities for subscribers who recently used less resources. Where is Colab? Colab Pro is only available in the US and Canada. So if you have an American credit card or a Canadian credit card, you'll be able to use this. Otherwise, I don't think you will. So we're gonna click on upgrade now, and I'm gonna put my credit card details here. So just checking that that's not visible here right now. And so let me just update and add my credit card details. Okay, sign up successful. All right. So now this is telling me that the sign up was successful. So I can check out this Colab notebook to see all of your subscription benefits in action. So let's go and let's see what this takes us. So making the most of your Colab subscription, faster GPUs. With Colab you have access to priority, so what we just saw. So we can now run this. What I mentioned before is that if we go here to runtime and we go to change runtime type, we can click on GPU, and now we get this new menu that wasn't here before, that is high RAM, right? So we can get hardware accelerated GPU as we were before, but we'll get better ones. So P100 and T4 instead of K80s when they're available, and then high RAM runtime shapes. All right, so we get that, we get this allocation again. So we get allocated a machine that has the requirements that we just put on the run type, and we get to see that here. So we see that we have a Tesla P100 PCIe card, and in order to use GPU with your notebook, select runtime, blah blah blah. More memory, so we can see here the memory thing. So your runtime has 27 gigs of RAM available. You're using a high RAM runtime, longer runtimes, blah blah blah, and then some feedback there. So yeah, this is in a nutshell, this is what you get if you sign up for Google Colab Pro. I'm not getting really anything out of it if you sign up, but I'm just using it because for the hours and the time that I spend there, I think it's worth having faster GPUs and cutting down on development time and training time. Also, $10 a month for these types of machines is super cheap. Like anything else that you use is going to be more expensive, and this is cheaper because you actually are getting something that Google is giving you as a gift to research and try TensorFlow. All right, I think I'm going to save these things with my scripts. So this is going to be iGPU, and this is going to be iMemory or iMem memory. All right, so these are text expansions, so I won't go through that right now, but these are text expansions. So same way that I welcome to Google Colab Pro, you can reset your runtime to take advantage of your new subscription, or continue and it will take effect for all new runtimes. So now I can change my runtime and get a high RAM runtime. And what I can do, so let's actually remove this. So I can do ITF to get this there. I can do iGPU. Yep. And I can do iMemory. So these are shortcuts for me to expand these texts, because these are things that you might commonly want to use. So we can see here there's a Tesla V100. We have some of the information here, and we get those 27.4 gigabytes of RAM. So thanks a lot for watching. This was Nono Martinez Alonso, and this was a short video on how to get your Google Colab account from normal to pro and what that subscription gives you. Thanks for watching, and I'll see you next time. All right, so that was just a tutorial, and we're gonna continue. So we're not finishing yet. We still have 1 more hour to go. And this is a public notebook, so we can see, we have our cells, and anyone who gets this URL or goes to the Discord channel, they can click on the link and they will see this code. I think they will also see the execution results on my cells. You can see now I'm not logged in, so I don't get the Pro here. And if I click here on change run type, I can get a GPU. But if we compare it, so we compare the results on my Google Colab Pro account and on the right normal one. So you actually have to sign in. So we're gonna try it right now. But yeah, you would get a different GPU card. All right, so this is a public notebook. We're gonna close that now. Let's save it. Let's say run all, and then save it so you can see it. And let's get started with the StyleGAN notebook. So while that's getting executed, I'm gonna click here again, change runtime. We already have the high RAM runtime, and we have our in my Google Drive, I have a folder that's called ML. So this is important. We're gonna be saving files there. And as a bit of background, this is a copy of this notebook, which is provided by, I think, NVIDIA themselves. So I think so GitHub, StyleGAN Colab notebook code and projection. StyleGAN2 Colab notebook. I'm not sure if this is the NVIDIA. Okay, this is a fork from NVIDIA. Okay, that contains a notebook, and we can, this is a feature that means, if you have the GitHub/Parth Suresh StyleGAN2 Colab, if you get the address to a Jupyter, so a Jupyter notebook that lives on a GitHub public repo, you can load it on Colab. So let's see that as well, actually. Yeah, so the question is from Sajed, like how did I configure text expansions for specific code blocks, right? I need to do a separate tutorial on that. Let me do one thing that I wanted to do as we move along the video, is that I want to also keep a list on potential chapters. So first we have start, and then we have we've been looking at intro. So we have StyleGAN overview, StyleGAN dataset preparation overview, StyleGAN, well, we'll just put Runway ML training overview. Okay, and now we've seen Google Colab Pro, and now we're going to see briefly Typinator, and then we'll go back to StyleGAN. So this is going to be potential chapters, that way it's easier for me to make them later, but I'm going to briefly show what Typinator is. So if we go to just search Typinator, so this is made by Ergoni, so that's the company that makes this product. This is a desktop application for Mac OS, which you can open here, and long story short, it's what's called a text expander, right? So text expander is a common concept. Well, the textexpander.com, that seems to be an app that just I don't know if it's the first one or whatever, but that's the concept, is that you have a piece of text and it gets expanded to something larger, right? So for instance, I use this all the time on the live stream and on my daily kind of code routine. So if I put here DSK, it expands to desktop, right? If I put here speed, it expands to a command with FFmpeg. If I put IP nono, so this is the IP of my server, I think I can put my IP, and this thing even executes a script that asks for my current IP address of my machine right now. And so these are text expansions. I also have for dates, so for example, date of today, or like date with timestamp, or the day of the month for some dates, right? So these are text expansions for other things. So let's say What else do I have here? Well, and the one you saw, right? So these are code expansions that just expands to a Python code. So for example, I just did this one, so I GPU, and then it prints that Python code. And I don't know if I have many text expansions. And how you would do that, and how I do this, and we need to do a more in-depth tutorial in this, not something that we can see quickly. But yeah, so if I put here a new group of expansions in this particular application, I can put here, for example, I don't know, let's say a website. So we want to make expansions for this StyleGAN Colab notebook, right? And for this ML folder. So we could say, we could go here, we could go into the abbreviation and maybe write StyleGAN and just paste this URL and make another one and write here drive and just copy the address of this page, right? So now even, if I close everything, I can open a new tab, I go here, I type drive, and then it pastes that address, and then I do StyleGAN, and then I get that expansion, right? So I have many different expansions. Like I have dozens or like hundreds, if not thousands of them, because daily I have to do many of these things. And the good thing that I like about Typinator, probably other text expanders, is that if we were to do something like this, so live date or something, so we could say will stream today, and then you can actually put here variables, right? So you can say, for example, September, and then the day. Let me actually check. I'm on the, okay, so I'm over. So what I was doing is, you can come here, so you say we'll stream today, and maybe put a comma, and I can put the month, or like the month here, so September, and I can then add the day, I don't know, at 6 p.m. or something, right? So this thing here will stream today, and these variables here, they expand to live date, right? So it says will stream today, March 11 at 6 p.m. And you can also do things like the clipboard, for example. So if you want to do something and paste the clipboard here, right? Imagine you want to put these arrows around something that you copy. So I copy this and I do live date, and then it pastes my clipboard here. So there's many things. I'm gonna stop now, but that's just an intro to text expansions with Typinator. Okay, so we are going to take a look now at training StyleGAN. So I'm gonna open here really quickly this slides again. And yeah, so I'm just gonna take a quick break. You're gonna drink some water, and we'll be back, and we'll start StyleGAN training, because that's actually what we want to do today. That's the kind of the core part that we're gonna do today. And thanks a lot for your question, Sajid. Feel free to ask any questions along the way. All right, we're back. So that was a short break, hopefully, and we're gonna close this. We're gonna go here, and we're going to start. Hi everyone, it's Nono here, and today we're gonna see how to train StyleGAN2, how to train a custom model with your own images and do that in Google Colab. You can do this for free in Google Colab, or you can also sign up for the Google Colab Pro version to get faster GPUs and higher runtime shapes. Let's get started. StyleGAN2 is an algorithm created by NVIDIA, and this is the second version. There are other versions that are evolving, but in particular, we're going to train today StyleGAN2. The notebook here was created by somebody who forked NVIDIA's original StyleGAN notebook, right? And more specifically, if we look at the URL here, we can see that this is a notebook that comes from a GitHub notebook that is here by Suresh. So let's give him some credit. I think he's the one who adapted this notebook, so StyleGAN2 Google Colab. I'm not sure. Let me see in the original repo. So in NVIDIA Labs, in NVIDIA Research Projects Lab, doesn't really have a notebook. So I imagine that what Suresh did is creating a notebook and then sharing it with the community. So link to Colab notebook. And at least for me, that's been really useful because I was able to get up and running relatively fast with StyleGAN. All right, so StyleGAN2 Colab, that's there. This is interesting. I didn't know you could do put a README here. And if you want to go to the original, you could go to this repository here and just click on the link. So you have the link here. This is the link of the notebook. So we click here, we open it, and you see this. So it's really similar to mine. This one uses the cartoon set 10K dataset. So let's see if we can see what dataset that is. So this is the one, right? So I have done some tests with it, and it actually learns pretty well the features because it's really consistent. The eyes are centered always on the same place. The mouth, the proportion of these cartoons is really consistent. You can see that here. All right. And what you can see if you go to this link that I'm going to make public now, and we're going to put on the Discord server, is, this is my copy of the notebook, and there are many things that are edited for the notebook to work with the way that I want to set up my data. For example, I mount my Google Drive folder here, or Drive, and that way I can load datasets to generate output, and I also can save models there. So that means that if the runtime gets disconnected, I know that the checkpoints of the models are going to be saved there, and then later I can download them from Google Drive and see how they're doing, right? And okay, so again, so if you're connecting today live, say hello on the chat, on the video comments, or join the Discord server and chat with us there. Okay, so I'm gonna do a quick scroll through the entire notebook just to make sure that I'm not missing anything. Let's actually clear all cells. So we have here a runtime, change runtime type, and we're gonna connect to it. And we're going to, how do we clear all cells? Clear all outputs. All right, so let me go to the right. It might be easier for you to see everything. All right, so we go to edit, and then we click on clear all outputs, and then all the cells are empty, so we can browse through the source code without seeing the output. So some references to the paper, the video, and code, and the Facebook HQ dataset are here. So it's important to understand what this network does. So this is style-based neural network architecture. And I'm not gonna go through this too slow, but the thing is, there are many features that can be encoded in this model, and you can choose to change certain features on the model, like noise. Well, not this one, but you can say in specific things, give me a face that's smiling, or give me a face that like is brown hair, or other features. And yeah, you can go watch the video to understand more, but there are many different data sets that have been tested with this. And specifically the Flickr Faces HQ dataset are faces at 1024 that initially were used to train a model, right? Like a StyleGAN model. If we see the original code, you have a table to guess or to calculate more or less how much time it is going to take you to train each of the each data set. Let me see if I can see it here. Yeah, so I'm not sure. There was another table. I think I put it on the Discord server. Yeah. Okay. Yeah, I'm not sure where that is. Maybe here. Yeah, so I don't see where it is, but we have it on the Discord server here, this image. And you can see that depending on the checkpoint you use and the resolution, and also for how many steps you're training, and depending on the GPUs that you have available, it will take you to train from scratch more or less days. Here, the fastest is 8 GPUs with like 256 by 256, which is 1 day. But if you want to train the high resolution one with just 1 GPU, that's like 70 days, right? This is crazy amount of time. You can train in like 4 or 6, 7, 8 hours with a checkpoint that you start from. If you start from this config F checkpoint, and you get pretty good results because the model already has learned how to do feature detection and how to some of the basic operations that this model needs to be able to work properly. All right, so let's see here. We have that. We had the Google Colab notebook, and I'm gonna go StyleGAN there. Okay, I was wondering what was happening, and actually dark theme, that's what I was missing. Okay, so this notebook has a ton of cells. Like it has a bunch of things here, and I'm not on the process of explaining the entire thing to you today, but what I can tell you is that this notebook has a few different parts. One that tries to mount the Google Colab, your Google Drive volume into the Google Colab notebook, and then we specify a few paths where we want to save our data to, and what dataset we want to be used. Then the dataset is processed to be converted into a format that StyleGAN can use, and then the training starts. The training takes many hours, so we won't be able to see a result, like a good result today, but we can see something and try to understand the process. And we then later, when the model has been trained, we have a process to generate images from the trained models. And there is some there are some things that we can test today from here, and then there's the projecting images onto the generatable manifold, which I haven't managed to get to work yet. All right, so first I'm gonna try to see what variables are on the notebook that we need to change. So the first thing is we need to mount the Google Colab drive here. So maybe what's easiest is if we try this first. So we run this cell here, and you're gonna see now that I need to click on this URL, which I'm gonna do here. What you have on that screen, you choose your Google account, you click on allow, so you allow access, and after that you're gonna get access to a token, and then my authorization code that is here allows me to access the Google Drive, and that's mounted there. So what this means is if I update my folder browser here, I see my sample data, but also my drive. So I can see all my contents there. And if we put these side by side, so I put my empty folder to the right and my notebook to the left, now we have a cell here, and I could do something like this, like touch, which is to just create an empty file at content, drive, my drive, ML, and then live 23 sample file, right? So I execute this cell, and what this is going to do is cannot touch file, not a directory. All right, so my drive, ML. Okay, so let's try just to list. Let's see what it says here. Drive, my drive. Okay, so they remove the space there, probably to make it easier, I think. So I mount that and do that again. Not a directory. All right. All right, let me just do here ls content drive, my drive. All right, ML. Okay. Okay, so I'm just gonna try to see what directories are there. ML. All right. Not a directory. All right, so there is some file that is getting mixed here. So there is both a file and a all right. So this is actually some model. I don't really know where this model comes from, but there is a file that is called ML on my drive, and it's colliding. The name is colliding with the folder. So I'm going to remove that, and I'm going to remove the folder. And now we're going to create a new folder. So let me just make this bigger so you can read. So we're going to make a folder if it doesn't exist, and we're going to call that ML. Okay. And if we run that again, that's good. And now we're going to attach, and we're going to add a file that is going to be live23 empty invalid. Oh, all right. So if we run again. Okay, so now you're connected to GPU but not utilizing the GPU. Okay. Okay, so now if we see the live, so the ML folder, you can see that we have this live23 empty file, and if I put something else here, you can see that that file will show up here once we update. It takes a bit to synchronize the changes, but here it is. And we could also remove it. So we could say, okay, remove everything inside here. This is a bit dangerous because you have access to your drive from code, and you could delete things by mistake, right? So now I've deleted that. So with this, what you need to think is we have access from Google Colab to the drive that we've mounted, and we have access to all the files on our Google Drive. And this arrow bang here means that I'm executing commands on the shell, so on the terminal. So if I go to my machine here and I go to my desktop and I make a temporary directory and enter that directory, you can see that the directory is empty, right? But I could do a new folder that is called ML, and now I can create a file inside it, right? And if I now list the contents of ML, there is a file there, and I could also remove it, right? We remove everything on that folder. That gets removed, yes, and that gets removed. So in Google Colab, we can do that, and that's really helpful for us to automate a bunch of stuff like saving files, loading files, overwriting files, renaming files, or even compressing folders and downloading things that we're using in Colab there, in case we don't want to download them directly from Colab. We also have a video, or I also have a video on how to download files from Colab. So I have an intro to Colab video that you might have seen in other live streams, but we also do have a video. Let me see if I can search here. Colab. Yeah, so how to auto download files from Colab. And this shows us how to, if you have a file, you can maybe zip it, or you have a text file and you can make the browser download it to your machine. That's another process you can do, but the process I'm doing right now, we will save the files to the Google Drive directly, and we wouldn't have the need to have the computer open with the tab where we're training open as well at the same time. All right, so let's remove this. So long story short here, we have access to our Google Drive from Colab, and we now need in this code here, we now need to take a look and see where we're loading our data set from. There is the possibility of choosing like a pickle file, a model file to resume from. If we see the output of training, what we get is these checkpoints, or are these checkpoints here, and also well, the artifacts that we're not going to see now. Let me show you. This is good because so what I did in this notebook is that every time you save a checkpoint, I also save one of the fake set of images that the model generates next to them, right? So we have these pickle files here. This is just like a way in which Python allows you to lets you save some data on the Python as a file, and then you can reload it back to memory. And this is an image of the generated images with that set checkpoint. You can see that the name here matches this one. So this is something that this notebook does automatically, something that I added. Before that was getting saved into the Google Colab instance, but I'm also copying it to Google Drive to have it in case that doesn't work. And you can see that from some of the first steps, I was training from the sketches checkpoint up to these portraits, right? So you can see if we order this by kind, right? So we put all the images together. You can see that even though these are sketches at first, it starts turning into faces. And the more time passes, the more it resembles the faces dataset, right? And then it sort of degenerates into something that I don't really understand. So it's overfitting some features that we don't really want the model to learn, but that's how it's happening. And this is what I'm doing is I'm saving here on a README file the process of training, so I can get an idea more or less of how much time it took to train. So this model took 7 hours to train, and at each point you can see more or less the state by those checkpoints. And then there's some artifacts there that are those videos that I showed before that we can generate also with this notebook. And these are the some of the videos these are the GIFs. Yeah, so these are good interpolations. And if we go to the models, so this is the models folder of what I've trained, but we can also go into the datasets folder. So the datasets folder is what we need to prepare now. So you can see this was one of the training sets that I used for the sketches one, and I augmented that dataset. So that means I rotating each image slightly to have more samples. I personally don't know if in this case, for this model, this is helping or it's making the model a bit more, it's making the model confused. But yeah, this is what I used for the training the portraits model. And it's also augmented in this case because I felt that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 images were not enough to get something properly working. I did that, so I didn't try anything else. And I have a data augmentation notebook that I use for this, that I believe is from that Live 20, or I don't remember. So that might be here. Hopefully that's here. Data augmentation notebook. Yeah, I don't know where that is, but I definitely added that somewhere. Yeah, we'll have to check. Oh, here. Yeah, so we had that from previous live streams. In live stream number 10, I go over how to do data augmentation. And in like 20 days ago, so that's probably 3 weeks ago, so that's live 2019, I think. So I actually used this notebook here, so I'll put the link on the Discord channel as well. And we augment the data that way. All right, so where were we? So we were taking a look here if we were going to use some checkpoint as the start point for training our model. And we are just, because we don't have that much time, so we are going to get these sketches augmented data set. So these are these images here, right? So there are many of them, and we're going to use this one. So for me, how it works the easiest is that I get a shared link from Dropbox, right? So I say copy the link, and I just copy that link, and I put that in a cell that is responsible to download that data set, right? So that's here. So that's the Dropbox data set. And by changing that, automatically the Dropbox dataset already gets downloaded. So in here, right? So we're downloading that into that Dropbox dataset into the content dataset images.zip file, because Dropbox, when you share one of these links, it automatically converts that into a zip file. You can see that if we go here, so to the desktop again, make the temporary folder again, and what we can see is we can do wget, and we download images Dropbox, for instance. We choose this name and then we put the URL. Not much is found. 1 second. Oh, it's an capital O. Let's see, is that it? Okay, yeah, so sometimes this happens. I just have to put quotes. So we run that, and after resolving that this is actually not a download link, wget actually resolves the download link, and then it downloads that zip file into the machine as you can see here. This process is the same that we're going to do on Google Colab, and maybe what we can do while this gets downloaded, and I'll show you something, is that I'm going to refactor a bit of these things. So we're going to put here a list of settings, and one of them is going to be our dataset download dataset link, right? So we have the Dropbox dataset, it just shows up here, so we're just going to change that there. And Dropbox checkpoint. So if we wanted to download a checkpoint that we want to use to train, we could use the same. So we have wget and then that. But actually, when you clone StyleGAN, there is already a checkpoint that we could use to start training from, because, you know, we're not going to use like a checkpoint for the sketches model, or like a sketches model as a checkpoint to start training the sketches model, right? All right, so we have here some code, and you know, this is not super fresh for me, but let me actually make this dataset link. Let's just put all the hyperparameters with capital letters, and that's there. And okay, one thing that I'm gonna do that I always forget this, I'm gonna go here into share, and I'm going to change to anyone with the link. Anyone on the internet with this link and view, and I could say comment or edit. So maybe even commenter. So I let anyone comment, and then copy the link, and I'm gonna put this on the Discord channel. So I'm gonna go here, I'm gonna go there, and we're going to put this here. So this is StyleGAN2 Colab training. So training Colab notebook. All right, so that's there as well. You can open it on your machine now and see the things that I'm editing. Okay, and now that's public, so you can all access it. And if we look here at the settings, we've mounted, so let's put titles as well. So mount Google Drive. This allows us to save artifacts and checkpoints to Google Drive and avoid losing our work if the notebook runtime disconnects. All right, so let's just make this short. Allows us the checkpoints to Google Drive, avoids losing work if the notebook runtime disconnects. Okay, so we have this here. Okay, so now configure, so settings, dataset link, configure what dataset, checkpoint, and hyper parameters to train with. Configure training dataset, checkpoint, and other hyperparameters. All right, so now we can move this cell down and move this cell down. So we have the settings, and we don't need this anymore. Okay, so let's start running things, right? So we've run this, we already, Drive already mounted. We have the dataset link thing, so we import here these dependencies that I feel that we could condense above because we're loading things in different places. But we're gonna move also this thing above. So our StyleGAN directory. This is also a hyperparameter. So this is StyleGAN directory, and we have that here and here and also here. So let's see, StyleGAN there, StyleGAN there. Yeah, okay, so it's only here, and this helps because we have to make the directory. So we're gonna put here, this is gonna be ML, and inside ML maybe we have, so let's see, so we have portraits and then we have models. So I usually like to do this, so StyleGAN and we might put here like live 23, right? Let's see what happens. So I'm gonna run this thing, and sometimes I like to keep these things here if they're only used in that cell, but these seems like they're gonna be used in more places. So maybe we're just gonna import dependencies here. So we can add those there. You know, I'm using this as an exercise to clean up the notebook a bit so it's more understandable, because last time I refactored everything, I didn't really have the time to sort these things. Okay, so we execute this cell, we execute this one, it's already mounted, we define these variables, and now we're going to put this here. No such file directory. Yeah, and the problem here is that I'm trying to create this directory here, but this one doesn't exist either, right? So I don't know if there was like make theirs Python. Directory recursively. Okay, so what we need to do here is OS make theirs. Right, let's try it. So just to make sure that we're understanding what's going on here, so the drive ML folder is empty. And when I run this cell, now that supposedly it has to work, then we don't really get any output. And that is because this is just the operating system trying to make directories. And you know, now this StyleGAN folder shows up here. I can click and I see the live 23 inside, and also the models directory, right? So what we do here is we have the models, and the models are going to be saved there. And also I think I have the artifacts folder, but maybe, just maybe, that is not in this notebook. And that might be actually because I do have, okay, so I just remembered that I do have another notebook. So StyleGAN predict, right? Yeah, this is good that I got to here, because I have another notebook that this one actually, that just downloads StyleGAN, make sure that those directories exist, and it just uses the so it has updated code to do the predictions. So this is a more updated code, I think, that we might be able to use. And we're also creating this artifacts directory. So let's create it, experiment there. All right, so okay, So let's try to merge them together so we don't have to separate code parts here. Experiment there. This is model. Okay, this is gonna be experiment there. Experiment there. Experiment there. Make theirs. Import time. So we're gonna take this to our dependencies. Get CW. Experiment there. Okay. Experiment there. Okay. So now that we have this working, so we have the models and artifacts folders inside of our experiment. So we could, let's say that we come back tomorrow and we have, like, now it's a different day, and then we say here, okay, now it's for portraits. So we can now run this folder, file exists. Okay. And yeah, okay. Great. And now inside of StyleGAN, we have these two different experiments, right? So we can remove them, and we could just say, okay, now it's just live 23, right? And then you run this again, and then that folder shows up here, and it's automatic. The idea here is that you only have to change the settings, and you don't have to worry about the other cells afterwards, and that's what I'm trying to do. Okay, so this tells us where we are. So we have drive and sample data. That's what you can see here, drive and sample data. And after we run this cell, it's going to this is going to clone the repository, so the StyleGAN repository, into the content folder here. Okay, and there is some code here that I'm using to load the model from either from Dropbox or from Google Drive, right? So the artifacts there, network there, that would be like, we want to save our artifacts, so the things that we generate, to a folder in the artifacts directory that has the same name as the checkpoint that we're using. That way we can keep track of what model we use to generate each of the artifacts that we're generating with this model. And I think this is a bit of a mess because I have duplicate code in two different parts, but not to worry, I think that's okay. So this is creating a save directory. So this is the network name. Okay, so this is the network name that we are using, and we can see here that the network path would be here, right? Assuming that that's a model that is inside of the models folder already, and the network snapshot will use the same name as a folder name there to save, right? So so this is actually code to save their network name. Okay, so network name can be a hyperparameter for us. So we have network name, because even regardless of whether we use StyleGAN's network or our one, we'll need a name, right? And depending on whether we're using that network for inference or for pre-training, then it might be located in a different place. So all right, so let me see. I'm just trying to think the best way to do this, but let's just bring this here. So we have here we have StyleGAN now, and we don't really have any checkpoints. I think the checkpoint download code I might have deleted. Let's take a look at the original notebook. All right, so okay. Yeah, so the train model is on CloudFront, so that is download training dataset and download trained model. So this is the default URL for the trained model, and it depends on whether we're getting the model from Google Drive or if we're getting it from the original paper, that we're gonna have to use different strategies to download that. All right, so let's assume now that we're gonna train from that one. So from the, okay, so the code is actually here. So this is okay. So let's add some text here. So here is clone StyleGAN2. Right. Here, what we're doing is create required directories. Right. So we're creating the required directories on Google Colab. And here we have the save directory. So this is so this is the artifacts. So right now we have we do have the models path, the artifacts there. And we want now to have something that is like the artifacts save there. And this is going to be, so we get here the network path. And we're gonna add a text here. So define network so that is called a resume. Define network to resume training from. Okay, and we're gonna put that here. So we have the network path and artifacts saved there. Artifacts saved there. Artifacts there, network name, and if that doesn't exist, we also create it. So let's refactor this. So experiment there. Ensure directories exist. Okay, and this, and so we now have, you know, experiment there. We have the models, and then we want to also artifacts there, to list the artifacts there. So, all right, so we do this. Network name is not defined. All right, so that's network name with a capital because it's a hyperparameter. So that is network name. Network name is not defined. All right, so I need to execute this cell and then execute this one. So now we can see that we have the models artifacts folder inside of experiment dir, and then we have the artifacts dir that contains the network snapshot, and that is defined by the network we're going to use as a starting point. Okay, so let's see now. So define network to resume training from. So the network path right now is going to be this one. So we see network path. This is what we're going to use for training. So this is network name, and it would be content, drive, my drive, blah, 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 models, network. This doesn't really exist because, I mean, we haven't really trained yet. So we can't really use that to train. And here we have two options. So if we were to download the network and put it there, so with that code that I showed before, with this code here, the train model, define train model, train network. Okay, so, you know, if we download this, so this is option 2, option 1, use a pre-train. So use a train network from Google Drive. Option 2, use a train network from NVIDIA StyleGAN2. Right, so in this case, we would download the file, but we can actually tell it where we want it to be. So we can say, okay, we want this to be in here, right? So let's see what we were doing before. We get Dropbox checkpoint. We can also download it from Dropbox, right? So we can also download a checkpoint from Dropbox, Dropbox checkpoint. Yeah, many ways, but at the end of the day, we just want to have the possibility. So, all right, so let's try this. So we don't have a model here, and what I can do right now is I can test the code to go from GitHub. Okay, so we don't have more than drive StyleGAN. Well, yeah, okay, so this has changed directories. Okay, let's see. Okay, so we can say this is the model name. So we have, we're not gonna do this right now. So we'll do network path. And if we do this, right, we're going to download the model from CloudFront, and we will get it wherever we are, which I don't know where it is. Yeah, I don't recommend you do that. So this is probably content. Yeah, I never really know how to open a folder here. Okay, so now here, maybe on StyleGAN, we've downloaded that checkpoint, but we don't really want it to be that way. So we want to download to content, StyleGAN2, blah, blah, blah. So we can yeah, so we can download it there. Okay, so network name, we could say this is the network name, and we want to download it. So we'll do this, network name and network name. Let's try again. So that downloads again, but it's now downloading here. So that's to the right place. So the network path in this case would have to be the, like just this. And we will download it, and then the path will get updated to what it actually is, right? And this is use a pre-trained network from Google Drive, and we can also option 3 is use a trained network from Dropbox, right? So we could download a network from Dropbox. And then all right, so the configuration here is really similar. So we can say this can be the network name. This is a bit tricky because we want to have, let me see, if I were to get another network from Dropbox, models, checkpoints. So if I were to get this, so let's say okay, so I copy the link, right? So now I have that link, so the Dropbox link is here, and I do have that that PKL thing here, so we could automate it in some way. Okay, so how do we do this? Okay, so let's say that network is gonna be one of 3, right? So we're gonna be able to have that one, and that one. Yeah, so we would always say network name equals if network split dropbox.com right. Let's just try this. So I'm trying to automate this part because otherwise we have to have a lot of manual labor every time we want to change the network and the mechanism through which we're acquiring it. So I'm just going to try to automate this. So let's first try to plot this. So let's see. Okay, 1. And if we get this, we get 2. All right. So this means that if this is greater than 1, print is Dropbox. And else is Google Drive. Okay. Right. All right. So now we have invalid syntax. Else if I don't remember. Okay. So it's Google Drive, which is good. Then this one is CloudFront, and then this one is Dropbox. Okay, great. So here we would do network name equals network split, and then we split by this, so it's 1, so 0, 1, 2, 3, 4, 5. So 5. And then network name. So for Dropbox, we get the network name, and then we do split PKL and then 0. All right, so that's a network name for Dropbox. That works. All right, so for CloudFront, I guess we'll do exactly the same. It's 0, 1, 2, 3, 4, 5. Okay, exactly the same code. Okay. And for this one, I guess same thing, but without this first part. All right. So, so this would be network source is Drive. Network source is Dropbox, or network source is CloudFront. So now network source. All right, so now we get from Drive, we're getting it now from CloudFront, and we're getting it now from Dropbox. Great. So for these two, I think it's the same. So so let's say this is just link. And this is link. All right, so now we will say if network source equals link, we would do this download. So we'll do, can we call this from inside? Probably not. So this would be network name, and this would be our link, which is the network. Yep, okay. Okay, so here we have, so we're gonna say if it's not Drive, so we can see here, this is, let's leave it here, so CloudFront and Dropbox. Okay, so give me 1 second. So I'm gonna take a really quick break. All right, so let's just put this here quickly, and I'm out. All right, let's keep going. So it's getting a bit, it's being a bit slower than I thought, but we'll try to make a bit more progress today, and hopefully I'll be able to clean up the notebook offline as well, and having a way that is super easy for you to use, and that is easy for us to retrain multiple times with different data sets. Okay, and if you guys have any questions, feel free to ask them on the chat. I'm happy to also stop and comment on that. So we're trying here to do, so our network path is, if we're not downloading from Google Drive, our network path will be this one. If we are, we will be using this link that we had before, which is the network path is our models directory plus the network name and the PKL extension. So that works pretty well now. So that makes a lot more sense. So we do want to specify this network thing up top. And right now we're gonna avoid the download, and we're gonna run this. So we run this with a simple network name, and so this is so this would be the network path. All right, so we do that, and we get that this is our experiment name, this is the drive, and well, this is a model name. This is we're getting this from drive, and this is the path to the model. So this is in case that we specify an experiment that we have been running and model name, right? But what happens if we want it from CloudFront? So now we have that, and we have the path to the model CloudFront, and this is the model name. And if we have it from Dropbox, we do have it in this way, right? Dropbox, content, blah, blah, blah. Okay, so define train network to resume training. Define train network name and path, right? Okay, so our hyperparameter is the network, indeed. So we should put this here. So we are not gonna have the network name as a parameter, not here. So we'll delete that. And we do need to move these two cells above. So this will go down. And now we have the settings, configure training, blah, blah, blah. So we don't really need this here. Define the network. So network source initially is drive, network source, network name. So network name, put that here. This is not a hyperparameter anymore because it's defined from the other directories. Experiment dir. So yeah, so that's experiment dir. So now we have this, so we run this and I run this here. So we know it's Google Drive, network snapshot, drive, blah, blah, blah. And we don't really need these statements anymore, but is Dropbox, so we have that. So we see that we're getting from drive, and if we were to use this here, we will get model artifacts, our model name, what is this? StyleGAN2 FFHQ config F. So this is because before we were using that model, so now we have these three model names in our artifacts directory. So we can see that from our Google Drive. So in artifacts, we can actually remove these directories, and that's it. Okay, so let's now once more just simply try that the other two types are working as well. So the network. Okay, so let's try with this one. So we run that, we run this one, and then we run this one. So now we get that artifact directory, artifacts, okay, and that should be here. So that's there. So that's for this model. So now for these 22 on Dropbox, so let's try for that one. So we define those paths. So it's from Dropbox, the download will be there. And now we get the same directory because the model has the same name. And for CloudFront, the model is indeed different. It's StyleGAN FFHQ. So we are running this cell. We get CloudFront. The model will be here. And then now we got that new folder for that experiment. So that will show up here as well. Right, great. So now we have our directories. So we don't really need this anymore. So I think we can safely remove this cell. And we won't remove this one, right? But I don't know if we can do this. Okay, yeah, so we ensure that we go back to content. And these I'm gonna leave above as hyperparameters that we might or might not use. I think this didn't really work last time properly. And so, and then for this thing, we actually want the model to be downloaded. So if let me actually save and reload just to make sure I see the menu. Save successfully. Okay, so I'm gonna reload here and reconnect just to make sure that we go to the root folder there. And just one sec. So if I open the folder now, I should see. I see that these are the contents of the content folder. So I can delete this, and I'm not sure if I can delete this thing. Yeah, so I could, I can simply run a code block here and say remove everything on content StyleGAN2. Right, so that deletes that folder. And now what you can see is so let's go and execute the cells. So I'm gonna go and execute these cells. So I import these things. I mount drive, which is already mounted. I define these hyperparameters, these settings. I figure out the path, and you can see here that this is CloudFront, and we were downloading the model into here. And network snapshot, CloudFront. So this is CloudFront, but the network name did not change. StyleGAN F. For some reason, okay, so network name was there and is the old variable. So let's make sure that this downloads to where it has to go. Okay, that's good. And now with this one, so let's make sure we remove these ones properly. I had a bug there. So we run this as well. So we download the model. And we can actually do here an optimization. So if OS, I think, Python OS file exists. Path is file. If not, all right, so now, we wouldn't download because it already exists and it's here. But now if we go back and run that, we download the file because it doesn't exist, and we put it here, and if we put CloudFront, we go and put it there. Yes, and if it were, if we run this again, we don't download because it's already there. And if it's this one, we just grab it from the Google Drive. All right, so we're there. So now we will go and we clone StyleGAN2 from GitHub. We now have that here, and we are gonna go to content again, so we don't really need to download these things anymore. So we go, where are we? We're at content, and now we need to have our dataset downloaded. We haven't downloaded the dataset yet, so we have the dataset link here. And we were mentioning before that will get downloaded here. Okay, so that downloads here. And yeah, this would be for the other dataset, which we're gonna remove to not distract. We're gonna put here download and prepare dataset. Right, so we download that, so that link gets, it's being downloaded from the settings that we put up there. Network pickle to resume. Yeah, these two things didn't work. I had some test code to some test code to parameterize that, but it didn't really work. So that's something that we're gonna have to probably change manually in here. Resume key image, and yeah, probably in here, and we're gonna have to put the path here. So this would be the resume network. This is the network path, and this is the KIMG from which we're starting. So this is, and I think we can put this here. All right, so this is executed. So this is going to verify our images. And this takes a lot of time because this actually generates big TF records from our data set. So that takes a lot of time. We'll do that the next session. And I'm going to see here what other things yeah, so there is a problem here that I wasn't able to customize the training code here. Probably we need to use external arguments, but these paths here are hard coded. So this is the models there. So this, so resume PKL, resume KIMG. So this is assumed, this is assume training progress. We also need to so this is the models there, and yeah, models there. So shootil, yeah, we don't need, well, yeah, we didn't need to import it there. Yeah, and this is the models there. So we could actually just say models there, and then the models there is this one here. So we could put it there, models there. Yeah, this is probably not the best, but you know, this is what I've got to. We need to do some optimizations in this file, and here, customize training variables. So this, I guess, goes to content StyleGAN. config ID, content saves. Dropbox checkpoint. So we're downloading the snapshot. So again, and this is already up top, so we don't really need to do this. And network pickle. So network pickle equals network path. And yeah, we'll have to see these things. I think I have better code here. So we are going to left it around here. So to do from here. Take a look at the StyleGAN2 Sola predict notebook. Okay. Yeah, so this is, it's been a lot of refactoring the code, and as a recap, what this does: loads on dependencies, connects to Google Drive. We set up our hyperparameters. We define the network source and the name, and then download the network if we need so, and establish the path where the network lives. Might be from Google Drive or from the the folder here. We create the necessary directories in Google Drive to be able to save create required, and this is Google Drive directories. Then we go to the content directory, and then we clone StyleGAN, and then after cloning we go back there, we download and prepare the data set. So we download here, we verify the images, we get up to 5,000 images from whatever we have. In this case I don't have more than 5,000, so we won't remove any. This is going to go through the images and open them and resize them to 1024 by 1024. And we go here later to create, this is to create the TF records. And then we go back to training, create the training loop file. We will need to replace this thing here and this thing and this other variable in there. In here, so this is the models there. Maybe we can actually specify that up top, so we don't have to put it here. So we put this here, models there. If we come up there, we can see that from the experiments that we're doing right now, that would be in here. So that would be this directory. And the snapshot would be this one. Right, so we will get this number from here, and this will be the folder, the models folder, which I'm seeing right now that we could obtain this. So we could say that models dir equals resume. Well, yeah, probably not a good idea, because this can be locally, but we might want to have this on Google Drive. And I'm going to, okay, yeah, so I'll give this a spin and try to see if there are any bugs on what we've done today. I think everything should be fine. This, you know, this is going to take ages, and it's not something that probably is going to complete today. Well, I mean, it could, it's not that long, but we're going to have to wrap up. And then we are missing the part of actually training and seeing how that responds to your own data set. And after that, we have to go from here, which is to generate images and videos from trained models. And that code I have here. So this is the predicting notebook, and in which I have some helper functions and some ways to visualize the generated images. I'm going to share this as well publicly to make sure that you can access it. And okay, copy the link. I'll put it on Google Colab, StyleGAN2 predict Colab notebook, put it there, remove this part here, and all right. So that is that for today. I'm gonna wrap now and we'll continue. So one thing I wanted to make sure I did at least before we go. Let's see if this works. Okay, yeah, so this is creating the TF records, and it's going to take some time. And you can see the size of the TF records is huge. It's kind of exponentially growing, and you get up to like 15 gig files or things like that. All right, so for this one, we didn't train StyleGAN, so maybe, just maybe, if you let me do so, I'm gonna do a bit of cheating here, and I'm gonna move these things down. All right. All right, and the one part that we've done is this one. So we're gonna save. All right. Okay. Great, so that should be our stream cover. I'm gonna close these things. And we're gonna go here. Hey, Mayur, I can see that you're connecting online. I thank you for passing by. I've also seen some of your latest live streams, and I have to say that I'm impressed. Some of those things are really good, especially the so you should check out a video that Mayur has, a live stream that I'm going to show right now on the different versions of YOLO from V1 to V5, I believe, and seeing the differences. All right, so where am I? Okay, save. Okay, so what I was saying, ng live YOLO, I think I watched that the other day. Where is that? Yeah, here. So I'll put a link on the channel. This is a comparison. I kind of skimmed through it the other day, and it's pretty interesting if you want to learn more about object detection. So this is on chat and links. Great. Yeah, and I'll share it here that we can leave the expansion with vargan. Yeah, thank you. I mean, it's really good. I can see that you're creating a lot of great content. Okay, so added 850 images. Okay, so it seems like it actually got generated. And just to wrap up, because I do have to leave. So we override the training loop. We execute this configuration here, and then after we get here, if everything's right, and I'm pretty sure that I made some mistakes, we'll get started with training StyleGAN. So let me, yeah, so this should be, now it's setting up the network and no such file, snapshot, blah, blah, blah. Okay, yeah, of course, because the model is actually not in there. So we could simply say that, you know, we've downloaded that from Dropbox, for instance. So we could do this and that here, and now we have redefined the network path. And now we can go back here, rewrite the training loop if that updates, go back here, and that might work. I don't know, but yeah, this is you know, something that we're gonna have to go more in depth. And yeah, well, Mayur, it means a lot that I'm hearing that you got inspired to do that from myself and Jose Luis. He'll be really happy to hear as well. And I'm really happy. We both got inspired by, I got inspired by him and also by Daniel Schiffman, a lot of other people doing live streams. All right, so model snapshot, blah, blah, blah. It's actually here, but not there because I've put the path in here. So I do really need to run. So, okay, so I'm gonna call it. I need to go, and I've done this part. I didn't do this one. We've shared the training Colab, so that was a reminder I put for myself today. Thanks everyone who passed by. Please like the video. It really helps support the channel and makes more people find about it. So go just click and like. I will really be thankful for that. Subscribe if you're not subscribed. You'll get notifications when I go live next or when I upload new videos. Join us on the Discord community if you want to chat. And yeah, thanks so much for watching, and I'll see you next time. Bye, and feel free to reach out. I don't bite. I'll be online. Bye.